In today's class, let us discuss about unary operator using friend function. So previously in last class we discussed about the unary operator and with normal member function, right? So if we declare it as a friend function, then how the syntax will be? So that we need to discuss. Only example we will discuss here. Okay. So it is just like the normal member function, but like a friend function syntax, the member function should be preceded by the keyword friend, right? So it should be preceded by friend keyword. It should be declared under public mode, and then friend keyword, return type, and what is that function name. Okay, so here we are going to follow the operator syntax. Okay, how we are going to declare the operator member function, that syntax we need to follow here. And another thing, if we are declaring unary operator using friend function, then it will be having one argument within it, right? So the argument is the reference variable. Okay, so this is the object reference. Okay, so this is how we are going to declare. And next we need to discuss about member function definition, right? If it is a normal unary operator overloading member function definition, then what we discussed previously, right? So here, so this is how we are going to define the member function. So this is just like the normal member function definition. But in the case of friend function, if we are defining the member function outside the class declaration part, we won't be using the scope resolution operator. Okay, so here you have to remember the friend function syntax as well as the operator overloading member function syntax. Okay, so here outside the class declaration part, if we are defining the member function, if it is a friend function, it will not have the friend keyword. At the same time, it won't have the scope resolution operator, right? So these things we need to remember, and just like the normal function definition, we are going to define it. So since we have supplied the argument as the reference, I'm assuming I dot x equals to plus plus I dot x. Similarly, I dot y equals to plus plus I dot y, right? And inside the main program also, if it is a friend function, no need to access it using the dot operator, right? And since it is a operator member function, we won't call it separately. What we will do, directly we will go for this particular syntax, plus plus I, right? So then automatically it will be invoked. Okay, so the member function will be invoked automatically. So this is about the friend function. So you should know to declare a particular member function, it may be a unary operator member function. So with a normal as a normal member function we have to declare, and at the same time as a friend function also we can declare, right? So both the cases are possible. So this is about unary operator overloading using friend function. Okay, next we will see about rules for operator overloading. So we have discussed the concept called overloading the operator. So which means the same operator will be used for more than one purpose, right? So then we are calling them as operator overloading. So what are the rules we need to follow for operator overloading? So only the existing operators can be overloaded. So the new operators cannot be overloaded, right? So whatever we have already, the operators which we are in use, the same operators can be used for different purpose. So which can be overloaded, but the new operator cannot be overloaded. That is the first rule, right? And the second rule is here, since we are using the operator for different purpose, its precedence and associativity cannot be changed, right? So this precedence and associativity concept you would have studied in C programming itself, right? So the precedence and associativity of the operators will not be changed. So based on their precedence only the operations will be performed, right? And at least one user defined operands must be used for overloaded operator. Okay, so without the operand we cannot use the operator. So at least one operator must be used along with the operator. Then only we can call them as the overloading concept, operator overloading concept, right? And the basic operator's meaning cannot be changed. Okay, so how we are going to call the particular operator, we are going to call in the same manner. Its name won't be changed. Okay, and some operators cannot be overloaded, as we have seen 4 different operators which cannot be overloaded, right? So like scope resolution operator and dot operator, size of operator, and conditional operator, they cannot be overloaded. That is another rule. Okay, and unary operator overloaded takes explicit arguments and returns no explicit value. right? So we have seen one example, right? For unary operator member function, if it is a normal member function, it won't take any argument explicitly, right? So if it is a friend function, it takes one argument. That argument is the reference argument. Okay. So these are the rules for operator overloading. Now let us discuss about binary operator overloading. So already we have seen unary operator overloading. So the next concept is binary operator overloading. Okay. So if it is binary operator overloading, then it will be having two operands, right? So the operator will be associated with two operands. So whatever operation we are going to perform for that particular operation, we will be having two operands. Okay. And the binary operator overloaded through normal member function will take one argument, whereas using friend function will take two arguments. Okay. So here we need to compare the binary operator overloading with unary operator overloading. You just remember the syntax for unary operator overloading. So if we are overloading the unary operator through member function, through normal member function, it won't take any argument in the case of unary operator overloading. Whereas in the case of binary operator overloading, it will take one argument. Okay, so why sure? This is the syntax. If it is a normal member function, we need to pass one argument. So which argument we are going to pass? So that we will discuss in the program. Okay, and if we are trying to overload the operator through friend function, okay, so it will take two arguments here, whereas the unary operator overloading, there it will be taking one argument. Okay, so here it will take two arguments. So the syntax is return type operator, and which operator we are going to overload, within bracket argument. If it is a friend function, here I have missed, it should be preceded by friend keyword, right? So friend keyword, return type operator op within bracket arguments. Okay, so two arguments we are going to pass if it is a friend function for binary operator. Okay, so in binary operator overloading, since we spoke that it will be having two operands. Okay, so in middle we are going to have the operator. Okay, so here what will happen? The left hand operator is used to invoke the operator function. For example, if it is a plus b, right? So here a is the left hand operator. Okay, let me write it. Okay, so if I have a plus b, okay, so here the left hand operator is used to invoke the operator function. Okay, so here we are going to perform addition. So to invoke the particular operator function, we will be using the left hand operator, and the right hand operator is passed as an argument. Okay, so this a value, what we are going to do with this a value? This a value will be added with which value? So with b value, right? So whenever the compiler sees the a value, then automatically the immediate operator which we have next to it will be invoked, right? So which operation we are going to perform here, whether we are going to perform addition, subtraction, what type of operation we are going to perform, so that will be invoked using the left hand operator. And once it is invoked, immediately we are having the right hand operator. So the right hand operator will be passed as an argument. Why? Because with this value we are going to perform addition, that is decided already, right? So with which number we are going to add, for that we will be passing this b value as the argument, right? So this is how the operation will take place. Okay. Okay, let us see one example for unary operator overloading as a normal member function. Okay, so here what I did, I have implemented the constructor concept also. Okay, so you would have remembered the constructor concept. So since wherever there is a possibility, we will try to incorporate all the concepts which we are discussing. Okay, so through examples only we can implement those concepts. Then we can understand all the things easily, right? So here I have created a class. The class name is complex. Okay, and what I did, so under private mode, I have declared two variables, x and y I have declared under private mode, right? Then under public mode, I have declared one member function, right? So this member function name is same as the class name. So if the member function name is same as the class name, and if it does not have any return type, then it is the constructor, right? So if the constructor does not have any argument, then it is called as default constructor, right? So simply I have used one default constructor here. Within that I didn't define anything, okay? So it won't give you any error also. Why? Because whenever the constructor function is created, whenever the object is created for a particular class, then automatically the constructor function will be invoked, okay? So anyway, separately we are not going to call this particular constructor function, okay? And then next I have created another member function, right? So this is also a constructor. So what I did, I have passed two arguments within this constructor member function. So whenever we are passing the parameters or arguments, we are going to call them as a parameterized constructor, right? So I have incorporated the parameterized constructor concept also here. So what I did, two arguments I have passed, okay? So here I am going to add two complex numbers, okay, and the result also will be a complex number. Since it is a complex operation, I will be having the real part and the imaginary part, right? As you all can remember, x plus j y, right? So that is the complex number, okay? So here real and imaginary part I have, and the real and imaginary values I have declared as a float, right? So inside that x equals to real and y equals to imaginary. And then next I'm going for the member function creation. So that is the operator overloading member function. So for operator overloading member function also, we are having the general syntax just like the normal member function. And you just see here, for this operator member function, I have given the return type as complex, right? You all can remember, like in float, we have one data type called complex, okay? So don't get confused with the class name, okay? So the class name also I have given as complex. Since I have created some member functions as constructors, I am using the same function name, okay? So don't get confused. And in this place, this complex represents which one? This complex represents the data type, right? So in this place, this complex represents the data type. So data type, and then operator keyword, and then the operand is, sorry, the operator is plus, right? So I'm going to add the complex numbers, and within bracket I have to pass one argument, right? So the argument is complex, okay? So what is the class? Okay, so the class name I'm passing here. Okay, so here I have declared the binary operator member function, and then another member function called display, right? So this is my class declaration part. So next I need to define the member functions which I have declared, right? So here already the constructor member functions has been defined. So now I need to define two member function. One is operator member function, another one is display member function. So I am defining the operator member function. So for that I am using the return type, class name, scope resolution operator, operator keyword plus, and then I am passing the argument where I have class name space the reference, right? So C is the reference here I am going to use. Okay, so inside that I am creating one temporary variable, right? So it is of complex type. So one temporary variable I am declaring, it is of complex type. So temp dot x equals to x plus c dot x, right? So similarly temp dot y equals to y plus c dot y, right? So and then return temp. So here what we are going to do, next I need to define the display member function. So inside display member function, I am going to display the result in the form of complex numbers. Okay, so simply I have given x plus jy, right? So this is how I am going to display. So you just see here, so this operator member function in general I have defined it. Okay, so if you see the main program, then easily we can understand what we have written there. Okay, so from the main program, what I did, I have created the objects, right? So how many objects I have created? 3 objects I have created. Okay, for the same class, you can remember the syntax. A single class can have more than one object, right? So in the same way, 3 objects I have created, C1, C2 and C3, right? C1 equals to complex of 2.5, 3.5. So what type of initialization is this? So parameterized constructor has been invoked with the help of this particular syntax, right? I hope you would have remembered the parameterized constructor syntax, right? So calling the parameterized constructor implicitly, right? So this is the implicit call. So we have two types of call, right? Implicit and explicit. Okay, so this syntax is for implicit call. So C1 equals to complex of this one. Then C2 equals to complex of, again I am passing another two values, right? C3 equals to C1 plus C2, right? Then in C out, C1 equals to what we are going to do now, C1 dot display. Okay, so whenever this particular line has been executed, the parameterized constructor would have been invoked. Okay, so these two values have been passed here. So one value, first argument has been assumed to x, second argument has been assumed to y, right? So since x and y values are assumed, what will happen when I display C1 dot display, then it will be displaying x plus jy. So what is the x value? 2.5 plus j, and y value is 3.5. Similarly, whenever I call C2, for C2 I have supplied 1.6 and 2.7. So what it will display? 1.6 plus j 2.7, right? Then I have C3. So what I did already, I have performed addition. So here only we are performing the operation, right? So C3 equals to C1 plus C2. So whenever the left hand operator C1 has been read, by the time itself the compiler will be invoking the operator member function. So when it is invoking this particular function, then automatically the control will come here, right? So for temp, we will be having x plus c dot x, right? So already we have two values. So one x will be holding c1 and c dot x will be holding another value, right? Then similarly for the next y value also. Okay, so we will be performing the y value also here. Okay, then if I display C3, it will also be displayed in the pattern of the added value of 2.5 plus 1.6 plus j into 3.5 and 2.7 will be added, right? So like 2.5 plus j into 3.5, right? And then similarly 1.6 plus j into 2.7. Okay, so what is the added value? This will be the C3 value. Okay, so since we have invoked the operator function here.